Hi viewers, I am creating these videos to support teachers of maths in helping pupils make sense of mathematical concepts and their associated procedures and processes. And today I want to look at order of operations, and in particular I'm going to focus just on a couple of operations, multiplication and addition, although you can make very similar arguments to the ones I'm going to make for subtraction and division and even indices. It's easier to do this manipulative wise if you stick to an index of 2, but you can make them for indices and multiplication and addition as well. And what I'm going to say straight away with this is we're not going to be talking about BIDMAS. BIDMAS ultimately is incorrect mathematically. It doesn't work. And although it can be potentially, some people find it useful occasionally, to be honest, it's the sort of thing that causes as many problems as it solves. So, from my point of view, and for me, I would be very, very happy if we didn't talk about BIDMAS or things like that and didn't use acronyms like that or PEMDAS or GEMS ever, because mathematically, for me, they simply don't make sense. And hopefully, you'll see why that is as we go through this. So, let's talk about a calculation that involves multiple operations. Let's talk about a simple calculation. Let's have 7 times 2 add 3 times 5. And let's think about how we might model this. Well, if pupils that already know something about multiplication, then there's a couple of ways that they might model this if they know stuff about multiplication and addition. And one of those ways is potentially using Cuisenaire rods. Now, if we already know something about multiplication, then we will know that that is a representation of 7 times 2. And similarly, this is a representation of 3 times 5. Okay, so I have here 7 times 2 and I have 3 times 5. And what I want to do is to add them together. Well, if I'm looking at this, then I'm looking at it and thinking, well, it's the area that represents these values. This area represents 7 by 2. This area represents 3 times 5. And there's no real way to sort of add those together and to evaluate the total area of those two when they are connected in reality without evaluating each one separately. I can do a little bit here, so I could potentially say, well, it's 2 times 12, add 5. But in reality, what I'm going to do is say, well, this has an area of 14, this has an area of 15, so I'm going to evaluate that as 14, I'm going to evaluate that as 15, and then I'm going to add them together to find that total area. And I can make a similar argument with counters representation here. So what I'm going to have here is I'm going to have 7 counters with a value of 2. So here we are, 7 counters with a value of 2. And then I'm going to have 3 counters with a value of 5. And again, if I want to add these together and I know something about addition, then I know that, well, I can't really add these together in their current form because they don't have the same unit value. And that's one of the key properties of addition, is that when we're adding numbers where those numbers are represented as objects, in order to add them, they have to have the same unit value. So what I would need to do potentially here is to change each of these 2's into 1's. So there are 2 1s for that 2, and 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 that 2. So each of these 2's can be exchanged for 2 1s, and then similarly, each of these 5's can be exchanged for 5 1s, and now they have the same unit value. Now I can add them together. And I can see here that because this is 2 by 7 array, this is 14, and this is a 5 by 3 array, so that's 15. And now I can add those together because they all have the same unit value and exactly the same as I had with the Cuisenaire, I will have 29. Now, if we contrast that with something like 7 times 5, add 3 times 5. And if I model that to say, right, well, here's 7 times 5, and this is a representation for 7 times 5 using, again, an area model of multiplication, and this is 3 times 5, but I'm going to rotate those around compared to what I had before. Well, now we can see, well, although I could evaluate this area and I'll evaluate this area and then find the total area by adding the two separate areas together, I can actually add those things and I can create a new single multiplication that is the total area. And I can see that actually what that gives me is 7, 8, 9, 10 by 5. So this is actually a 10 by 5 area. And so, in fact, there is no need here to do the multiplication before the addition. It depends on the properties of the things that we are adding. And this is the thing that really sort of puts the nail in the coffin for me when it comes to BIDMAS, is that depending on the multiplications, you may or may not have to multiply before you add. And pupils recognizing that and appreciating that is an important part of their learning of number and arithmetic. And, of course, what we're doing here in effect is we're applying the distributive law or the distributive property in saying that this is simply 7 add 3 times 5. And pupils seeing this and recognizing this is laying all sorts of wonderful groundwork for when we're going to talk about factorization of algebraic expressions, or when we're we're looking at calculations involving large numbers or decimals, and we want good strategies for those things. And you simply don't get that if what you're teaching pupils is BIDMAS, do brackets, indices, division, multiplication, then addition and subtraction. You don't get that same fluency, that same flexibility in strategy. And we can see the same thing again with the counters here. We can say, right, well, if I have 7 counters worth 5, and this is obviously a unitized view of multiplication, so it's multiplication by grouping in effect or by unitizing. I'm creating 7 groups of 5, and then I'm creating another 3 groups of 5. Well, again, we can see that, yes, I could work out what these 7 5s are in ones, and I could work out what these 3 5s are in ones, but actually there's really no need to do that. I can just add these together, and what I have is 10 things worth 5. So I have a row of 10 5s there now, 10 groups of 5, 10 units of 5. And again, there's no need for me to be doing the multiplications first there. Because of the nature of the things I am adding, I can just add those together. And whether it's because you're looking at it as a sort of unit and adding the same unit, or whether you're looking at it in terms of this distributive sort of idea and reversing the distributive property in effect by recognizing that common factor of 5, either which way, the crux of that matter is it depends on what you're adding as to whether you actually have to do the multiplication before you add. And there's the sort of problems that we might utilize this with, and I'm not going to represent these, but if we have something horrible like 98 times 37, add 2 times 37, we don't want to be multiplying before we're adding there, do we? We don't want to be following the laws of BIDMAS, whatever they may be. We want to be saying, that's 100 times 37. We want to be adding before we multiply there. Or, even better, something like this. (7.8) times 1.6, add 2.2 times 1.6. we want to be adding those before we multiply. We want to be recognizing a constant unit of 1.6 and saying, well, this is 7.8 of those, add another 2.2 of those, that's 10 of those, that's 16. And I definitely do not want to be carrying out the multiplication there in the same way as this is just 3,700. And I definitely don't want to be carrying out the two separate multiplications there before I add. And like I say, although I'm not modeling them here, we can make very similar arguments for multiplication and powers by looking at, and again, it's if you're going to model those physically, certainly with something like Cuisenaire, then it's best to stick to power 2. You can just about stretch to power 3 with Dinesh blocks. And using the big block there. With counters, it's a little bit easier. You can use sort of counters that have a value of 5 squared or 5 cubed or 5 to the power 5 or whatever else. But then it's harder to convert those into ones if you're in a position where you can't add or subtract. But you can do very similar things with those sorts of bits. But this sort of flexibility, knowing when I can add before I multiply, or when I'm going to have to multiply before I add, or at least do some multiplication before addition in order to create this common unit, or in order to evaluate these separate areas, or have whatever model for multiplication, powers, whatever operation it is we're using. It's that fluency and that flexibility that we should be aiming for, not just BIDMAS, follow those letters one after the other, or even, some people now put the D and the M on the same line and the A and the S on the same line, but it's still nonsense. We still don't always need to multiply or divide before we add or subtract. Distributivity and the other properties of arithmetic, commutativity and associativity, tell us something about what can be added, what can be multiplied, or like I say, unit values tell us something about when we can add before we multiply, or when we have to multiply before we add. So for me, teach kids about what it means to add, what it means to multiply, what it means to power, what it means to divide, and get that flexibility about, okay, well, can I add in this situation? Can I subtract? Can I divide before I evaluate these powers? And, even simple stuff like something like this. 3 times 5, add 10 squared. I can do the 3 times 5 first there. There's no issue with that. I could do the 3 times 5 before I do the 10 squared. There's no need for me to have to evaluate 10 squared first. What I do know is that I can't add those in their current form. Not just looking like that. I can't make sense of that addition. But I can do the multiplication before I apply the index to the 10. What I can't do is in something like this, multiply the 5 and the 10 before I apply the index. But again, that comes down to me knowing good models for what it means to power, to square an expression, what it looks like to multiply. But if I develop those ideas instead of this idea of BIDMAS, then I get much more flexibility and much more fluency around those calculations than I would do just by following a set of made up, and they are, let's face it, ladies and gentlemen, they are, or people, sorry, they are made up laws. So that is my video on order of operations. Hopefully you found that useful and informative. As always, I'd like to say a big thank you to mathspot.com and its creator, Jonathan Hall, for providing this fantastic website that I use to create all these videos. I use the manipulative section, of course, but it's not just the manipulative section. There are all sorts of wonderful things on that website which will make your life easier as a teacher of maths. So if you haven't yet had a chance to go through that website, please do try and make the time to get into that website and think about all the things that it could bring to your practice. And if you are interested in particular in using manipulatives and visuals to support your practice and support your learners in making sense of mathematical ideas, then please do consider going to my website. My website is visiblemaths.co.uk, and among the many things you'll find on there, you will find a link to my book, which is also called Visible Maths. That's why the website's called Visible Maths. And there's a section on my website there called Visible Maths Book, and in that section you can find a link to the publisher. The publisher is Crown House Publishing, and you can see some sample pages on their website. And if you feel like it would be useful for you and for your practice, then of course you can place an order. I'll be making these videos throughout lockdown, and hopefully, if I find time to, beyond. So if there is a particular concept or process or procedure that you feel like you would want looked at and modeled using manipulatives or visuals, then please do get in touch, and I will endeavour to get round to creating it for you. Thank you very much for your kind attention today.